Hello students, today we'll start the new chapter, that is the chapter 9, Mechanical Properties of the Solids. So this is the part 2 of your textbook, NCERT textbook. So let us start the mechanical properties of solids. So first of all we'll see the introduction of the chapter. A rigid body. It starts with a rigid body. So here in this chapter, solids means it is a rigid body. Rigid body is a body which has a definite shape and size. So you all know that a rigid body is a body which has a definite shape and size. So for example, a metal rod, okay, a sphere which is made up of metal, so which is rigid, which cannot easily deform into other shape, which cannot be deformed. It is known as a rigid body. A rigid body can be stretched, compressed and bent when sufficiently large external force is applied on it. So this one sentence you have to note down. So it can change. There is no ideal rigid body, okay? But when we apply sufficient large external force, it can be deformed. Deformed in the sense it can change in the, it can be a change in the size. So sizes, for example, length, volume, okay? So this is that means when there is a external force, deforming force applied on a body, it will change its shape and size. Okay, now let us see what is a deforming force. If the body suffers change in length, volume or shape, the body is deformed. We say that the body is deformed, and the applied force is called deforming force. Okay, so now what I'm trying to tell you is, what is a deforming force? If the body suffers change in length, so for example, if you take a wire and you apply a load to this wire and go on increasing the load downwards, what happens is there is increase in the length. So that is how much is the length. Suppose if L is the initial length, so the change in the length will be plus delta L, okay? So there is a change in the length, okay? So it will be stretched. Now it is deformed. It is increased also means it is deformed. It is decreased also means it is deformed, okay? And if you take a sphere, for example, you have seen the shot put, okay, sphere, and now if we apply the force in all sides of this sphere, what happens is this body can shrink, okay? So the how much will be the shrink? There is a change of volume delta V, okay? The volume has changed to delta V. So this is known as the deforming force. The force which we apply to a body to change its length, volume or shape is known as that force is known as the deforming force, okay? So now let us go to the next slide. Okay, so what is a restoring force? A restoring force is a force which opposes the deforming force, which is developed internally, which opposes the deforming force. A force which is applied internally of the body, which is there already in the body, it opposes the deforming force, okay? So that is known as the restoring force. You can see it is visible now, okay? So here you see it is known as a restoring force. So restoring force is nothing but a force which is, when the rigid body is deformed, a restoring force is developed internally which opposes the deforming force, okay? Now let us see what is elasticity. So you can see in this picture a person is pulling a spring. So now initially the spring is of length, for example, L, Now if we stretched, there is increase in the length, right? So this property of the spring is known as elasticity, and if you remove the deforming force, it comes back to its original shape, okay, and size. Elasticity, let us see the definition. This property of the body, of the material of the body, by virtue of which the body regains its shape, original shape and size after the removal of deforming forces, is called elasticity. Okay, I will repeat. The property of a material of the body by virtue of which the body regains its original shape and size after the removal of deforming force is called elasticity. Okay, for example, a rubber band. Okay, so when you stretch a rubber band, a string, then it will pull itself to a certain limit, that is known as the elastic limit. So now if you again remove that stretch, when the stretching force is removed, the rubber band will come back to its original condition or shape. This is known as, this property of that rubber band is known as elasticity. Example, elastic bodies. What is next? Let us see. What are the elastic bodies? The bodies which possess properties of elasticity is known as elastic bodies. Possess properties of elasticity. I will type here. Property of elasticity. Yeah, are called elastic bodies. Okay. Now let us go to the next slide. Elastic limit. The upper limit of the deforming force for which the body can regain its original form is called the elastic limit. Okay, that means it is a limit up to which it can withstand that deforming force, and again the reforming force come into existence, and they pull all the particles into to oppose the deforming force. This is known as the elastic limit of the body. Okay, now let us see the elastic behavior of solids. In the picture you can see a diagram. Here you can see there are springs, and these black dots are the atoms. You can see the balls here. This is known as the spring ball model. It is known as the spring ball model. So now let us see. Let us now understand the elastic behavior of solids by spring ball model. Every substance is made up of atoms or molecules. So all the substance in the universe is made up of atoms or molecules. From the given figure, let us assume that the balls represent the atoms and the spring represent the internal reforming force. So this spring represents the internal reforming force which connects the atoms from one to another whenever the deforming force is applied on the substance. So now if we apply a force here, okay, this spring has a tendency to either expand or compress. Okay, now if the force is within the limit of the elastic limit of this body, again the body will regain its original shape and size. But if the external force is very high, higher than the internal force of the reforming force of the spring body, then what happens? It will lose its tendency, or the spring may break also. Okay, so whenever the deforming force is applied on the substance, the body resists the deforming force with the help of the spring. If the deforming force is small, then the body can come back to its original shape and size. If the deforming force is greater, then the restoring force of the spring of the body loses its shape and size. So that's what I told you. So this is known as the spring ball model. Now let us go to the next slide, stress. So a very important definition and also equation. Stress. Stress is the internal restoring force developed per unit area of a deformed body is called stress. Okay, so it is given by restoring force by area equal to deforming force by area, that is F by A. So whatever force we are applying is applied on a body, the force, it may be weight, a load or a stretching, whatever it is, however you are putting the stress on the body, so stress is given by force upon area. So what is the SI unit of stress? Newton per meter square, and dimensional formula is ml raised to -1 t raised to -2. Okay, so this is the stress. Now we will go to the types of the stress. There are three types of stress: longitudinal stress or normal stress, tensile stress. In the longitudinal stress we have two types: tensile stress and compressive stress. So let us see longitudinal. Longitudinal means, by the name itself we can understand, it is the stress which is applied to the lengthwise. Okay, if the deforming force acts along the normal to an area of a body, the restoring force per unit area of the deformed body is known as longitudinal or normal stress. Longitudinally means it will increase in the it increases normally, perpendicularly. It is known as the longitudinal stress. There are two types of longitudinal stress. One is a tensile stress and compressive stress. Tensile stress is when the length of the body increases in the direction of the deforming force. So here in the first diagram you can see, so how the deforming force is, the length has increased delta L. So let us say the original length as L, and when the applied force is there, F, then there is an increase in the length delta L. So there is increase in the length. So what does the tensile stress say? When the length of the body increases in the direction of the deforming force, the restoring force per unit area of the body is called tensile stress. Now let us see what is compressive stress. Compressive stress is the opposite of tensile stress. That is, when the length of the body decreases under the action of deforming force, the restoring force per unit area is called compressive stress. Okay. Now these are the two types of longitudinal stress. Second one is the tangential stress. When the deforming force acting tangentially to the surface of the body changes the shape of the body. Okay, the restoring force per unit area of the body is called tangential body. So you can see in the figure here, the lower part of the body is fixed. When you apply the force only on the upper part of the body, it will be a shift in the angle of a body. Okay, so this is known as the tangential stress, and theta is the change in the tangentially, and when the stress is applied tangentially, that is delta L is the change in the length to the original length. Okay, now what is known as the hydraulic stress? Hydraulic stress or volume stress also we can call. When a body is compressed from all sides by the application of deforming forces, the restoring force per unit area of the body is called the hydraulic stress or volume stress. So I told you, when we take a sphere, when we apply the force on all the sides, you can see in the figure, in the diagram, hydraulic stress. So here the force is applied on all sides of the sphere. There is a shrink in the volume of the body. So how much is the shrink? That is delta. I can zoom. So delta V is the shrink. Okay. So here this type of stress is known as the hydraulic stress. Right. Now let us on the volume stress. Strain. Let us see what is strain. Strain is when a body is deformed, the ratio of change in the configuration to the original configuration. So what do you mean by configuration? Configuration, it may be lengthwise. Configuration is nothing but the dimension. Okay, length or the tangentially, or it may be the volume. Okay, so this is known as the configuration. So when a body is deformed, the ratio of the change in the configuration to the original configuration is called strain. Strain is the dimensionless because both the configurations, so the unit cancels there, so it is a unitless quantity. So it may be the change in the length, change in volume or shape. The strain is of three types. Again, here also, as we have seen in the stress, the strain also has three types: longitudinal strain. The longitudinal strain is defined as the ratio of the change in the length, delta L, by the original length. So delta L is the change in the length divided by original length. This is known as the tensile strain. What is volume strain or bulk strain? Volume strain is defined as the ratio of the change in volume to the original volume. It is also called the bulk strain. Volume strain equal to delta V by V. So volume means delta V by V. Okay, now let us see what is shearing strain or shear. Shearing strain is defined as the ratio of the relative displacement of one plane to its distance from the fixed plane. So as we have seen for shearing stress, so the same thing, the same picture you have to refer, where the upper portion is applied by the force and there is a change in the dimension by theta. So delta L by L equal to tan theta theta. This is a shear strain. Okay, so now let us go to next slide. Theta is the angular displacement. It is measured in radian and it is defined as the angle through which a line originally perpendicular to the fixed plane turns on the application of the deforming force. Hope you have understood. If you have not understood, please go through the video and clarify. You can clarify the doubts. Thank you.